Assalamualaikum warahmatullahi wabarakatuh, and good morning to our lecturer, Dr. Izzuddin bin Supi. Today we are from Group 4. We'd like to present about our experiment 2, which is called single stage compressor. Our group consists of 5 members, which is Nur Amira binti Zamros, Nur Azazin bin Nordin, Muhammad Fizri bin Hazim, Nur Diana binti Abidi Rahman, and me, Nasri Aina binti Muhammad Nasir. So the objective of this experiment is to observe on how heat is converted to work.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and hello. My name is Muhammad Fizri Hazim Ismail from Group 4, and right now I'll be explaining about the theory for experiment 2. Okay, from figure 1, a standard single stage vane compressor is shown. But what is a compressor? Okay, a compressor can be briefly defined as a mechanical device which increases the pressure of a gas by reducing its volume. Okay, within the compressor, air with a fixed volume is trapped between two driving sliding vanes driven by an offset rotor, which means the vane is powered by the rotor to move. But what does vanes mean? It can be defined as a thin, flat or curved object that is rotated about an axis by a flow of fluid or that rotates to cause a fluid to flow. So in this case, it is the second definition, which it rotates to cause the air entering to flow. Okay, next slide. This volume of air is then pushed to the outlet, which both the area and volume are reduced. As a result, the pressure increases, hence forcing it out of the outlet port. I think that's all from me. Moving on to the next presenter.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Diana binti Abu Rahman, and I'll be explaining about the apparatus and the procedure of this experiment. The equipment that consists for the single stage compressor are: first is the air flow meter, where the atmospheric air will start to flow through it. Next is the inlet valve, which we can control the airflow. Third is the first air chamber. Next is the motor and power switch box. Then we have the compressor, where it is worked by the motor. Next is spring balance. Then we have the second chamber. Next is outlet valve. And we will be using another two equipment, which is barometer, which is to read the atmospheric pressure, and also tachometer, which is to read the speed of the motor. For the procedure of this experiment, first, the power was switched on. Second, the green inlet valve was fully open. Next, by using a tachometer, the reading of the motor speed was recorded. And at the beginning of the experiment, the initial readings for all parameters listed in table 1 needs to be recorded. Fourth, the motor was switched on. Then, the compressor outlet pressure, which is P2, needs to be set to 1 bar using red outlet valve. Make sure the valve turned into clockwise in order to increase the pressure. Next, to ensure the indicator on the motor was between two black lines, the spring balance needs to be adjusted prior to recording any motor force values. Lastly, the temperature of the outlet air T2 was recorded at 1 minute intervals, for example, by using stopwatch until two consecutive readings were the same. And to stop the experiment, the compressor outlet pressure P2 was reduced to 0 bar gauge by using red outlet valve. And lastly, the motor and power were switched off.
I am Nur Amira, and I will proceed with the data analysis and results. Based on the data given, which is length of torque arm equals to 0.2, compressor swept volume Vcomp equals to 267, specific heat capacity of air Cp equal to 1005, and tables of parameters for single stage compressor, we can extract the information and calculate for the specific volume through flow meter V0 by using formula V0 equals to RT0 over P0, which is V0 we will get 0.846 meter cube per kg. Then we calculate volumetric flow rate V equals to V in over 60,000, and we will get V equals to 0.005 meter cube per second. After we get V and V naught, we can simply divide 0.005 meter cube per second over 0.84602 and get mass flow rate equals to 0.00591 kg per second. Next, we can calculate the power of meter Wm with formula motor speed times motor spring balance times length of torque arm times 2 pi times 9.81 divide with 60, which we will get 804.3528 watt. We also have table 2, which is the outlet temperature data, where we will calculate energy added to air by compressor, HC, and energy emitted to the compressor, QC, using all the data given and calculated before. For HC, we will use the formula of HC equals to mass flow rate times specific heat capacity times T2 minus T1. Like the example I put here, for T equals to 1 minute, HC equals to 0.00591 times 1005 times 69 minus 28 degrees Celsius, and we will get HC equals to 243.523 watt, and continue calculating for every minute using the same formula. And lastly, for QC, we use the formula of power of motor minus the energy added to air by compressor. Referring to my example here, for T equals to 1 minute, QC equals to 804.3258 minus 243.523, and we will get QC equals to 560.830 watt.
Hi, my name is Noor Azim Bernuddin. So today I will be discuss about discussion in the experiment 2 single stage compressor. So the first question is, we need to analyze the shape of graph, heating curve, and the related thermodynamic phenomena occur in the graph. So for the graph 1 and 2, we can analyze that heating up the curve, while the graph 3 is heating down the curve. The two thermodynamic phenomena we get from the graph, which is heat gain and heat loss. Heat gain occur when the energy of a molecule and internal energy of system increase. But for the heat loss, energy transfer out because heat from molecules come in. So for the graph 2, energy risen over time because it happened because the compressor occur just a small amount of pressure and energy for the air to exit the compressor. So the last one is work can be transformed into energy flow involving a force working over a distance. So we move out to the question 2, which is, what happened to the energy that is being input to the system when the system is heats up? So first one, compressor will heat the air in the system. So the temperature of air will increase and stabilize, which when it reach the stabilize, it will reach this equilibrium with the system in the compressor. So energy input is absorbed by the system, and the excess energy is lost at the atmosphere in form of heat. Then the last question is, we need to compare the amount of energy loss as heat with the work input to the compressor and the heat added to the air. So for the work input compressor, so the amount of energy loss as heat is lower compared to the work input to the compressor we get from the experiment. So for the last one is, the amount of energy loss is higher than heat added to the air at the beginning of the experiment. But after 10 minutes of the experiment, amount of energy loss become lower than heat added to the air until end of the experiment. Okay, that's all.
So I'll be explaining about conclusion. In this experiment, we can conclude that the outlet temperature T2 increases exponentially as the time increases. This is due to the heating process. The single stage compressor heats up the air in the short period of time. As temperature outlet T2 increases, the energy Hc that is added to the air by the compressor also increases. However, the heat emitted from the compressor QC decreases. Steady state is achieved as QC at the temperature is the steady state heat loss at a single stage compressor in this experiment. That's all from us. Thank you very much.